Yeah, we're looking at it in a very, that's the idea. We're working at it in a practical way. Yeah, and I mean, Dino, that's how we first got introduced. He came to our conference and saw my speech on multidimensional chaining, which is kind of my idea. Kind of think about it more like a graph, a grid rather than a linear chain structure with kind of multiple parallel processing channels with their own state in them. Kind of like we're kind of doing a good analogy of like the topology of the internet in a way where you have your initial routes that come from the DNS, and you go to the ISP layer clusters, and then they go through their own internal routes, -8, -16, -32, eventually down into like your low-level internal network and your routes. So I mean, the idea is kind of like layers of consensus like that. Yeah, but still remaining cryptographically secured and on-chain, and then utilizing that as a way to kind of prevent data corruption, which tends to come, or someone trying to manipulate it, or you having partitions or shards.
ILA one and his
SMR some of them.
One.
Earlier,
Seems no problem.
the sharding is a way to do linear scaling.
Thomas is doing a presentation.
It's a very particular process. It needs to be implemented very carefully.
In another group, and he wanted to be here for the ILA one for obvious
Well, yeah,
reasons.
and
So
I guess you can say maintain the
one
integrity of
slot.
the data, and also have a bad actor not deliver bad
Not
data,
overweight,
because you have
not-
transaction ledger where there's previous dependence
I
upon previous dependence. You need to make sure that all of that data is valid. Otherwise, you could be just verifying a transaction is true if you don't have the previous prerequisites. You need to have a way to receive that data.
pretty short.
So, I mean, our idea of the
So you're
sharding
not doing
partitioning
much
model
good, but he
is
asked that we
parallel
make
state channels that are happening in real time, but still
He's
maintaining a
doing
global
1,
consensus,
2,
but having layers of
4.
hashing. that can
I said we could easily
so
move
you
it,
have,
move.
the
one
basic
down.
processing channels.
That
which
seemed
are
like a no-brainer.
I guess you could just say modded between one another. You're assigned a different channel based on the capacity and needs of the network. And then you have kind of a proof of stake to consensus model on top of that links them together to creating the horizontal grid. Right, and that
these levels could be multicast groups.
yes, the multicast groups, yeah.
Authenticated.
And then we're working on, we're integrating this into LISP.
So that's what he co-authored Lisp Decent with me.
Yeah, so we're working on, we're working on figuring out tying the crypto ID because I'm making.
While I was doing it.
Yes. We've been geeking out on this
it's
for a
just
while.
not cryptocurrencies. It's like emergency networking too, right?
Yeah.
Yeah.
Even the core of this thing I'm talking to you about.
Yeah.
Use some.
Yeah.
Exactly.
Well,
See,
it's
but I
kind
mean-
of funny you say that because I'm saying what Lisp could help the crypto layer, and they're
vice
saying
versa.
how Lisp can be helped by the crypto layer.
Yeah, the mapping system being distributed and having the key, kind of having a key system in there.
I love
So
what scene. I
that's
wasn't
we're
even
talking
sure
about
you'd
signature
made it.
chain, which is your own
Because
kind
I
of
didn't
identity
see
system.
you.
The data publishing system is built into it too. Kind of like how on the routing layer, you just
I was
forward
in
the packets and
I2RS.
you're routing them where they need to go. That's kind of the idea of the distributed
I
ledger. At
was
least what
at
I'm designing
the,
is
I was at
the
newcomers,
router
newcomers
doesn't
and
really know.
social.
The database doesn't even really know what the data means. It just needs to know the data goes here, and it's basically signed off and passed to this person, and this person
I
now
was
owns
here.
it. And then
I
on the
arrived
higher
Saturday
layers, it's
morning.
where you do the interpretation of the data. A lot of blockchains are doing that all right on the core layer, which is a little bit more than necessary.
You're facing is more important than an opinion. So I'm gonna cut in this big deficit.
Well, I'm here all week.
When this,
I have time at the after
It's
this,
a log.
because my next appointment's at 4:30.
I have to eat the
Last day or so.
Oh, right, you have to be at Inter, yeah? Yes. That's what I was going to go for until I ended up with a
protocol
conflict.
addresses recent mapping servers and being online,
Yes.
where you can basically talk to the network and you can find a list of them. and
Resource
then-
discovery, yeah.
Yeah, resource discovery, and then you can check and balance them off of one another to make sure you don't have bad actors. And then we're talking about a little bit of proof of work on each request or something of the
Yeah.
sort to prevent DOSing.
Yeah.
rather than I've been ingesting all this data for 3 days.
Uh-huh.
What about this?
That's
Yeah.
the next working.
Well, instead of that, heavy lifting was smart about it.
Oh, so maybe could the blockchain be an archive too and all that?
That's the idea. Remember I was talking about checkpoint states? once you get to a checkpoint state, then you don't need to have the global consensus. And
That's
that's where
for
you
the
put,
older stuff, yeah.
then you just have the checksums or your list or your skeleton of it. You don't have to have all the body of the data.
Mhm.
And you can verify those checksums, and then you can kind of understand that. And you can just hash it all the way up back to that checkpoint if you want to get everything, and then you can verify that checkpoint hash fits within the scope of all of the historical data. So you just choose your validation level of what
Right.
security level you want. That's the idea. We're working on 3.0, and I don't think they're going to be called blockchains in the future.
Right.
But I think a lot of people are rushing to market because it's so competitive, and we're just, hey, we're here cooperating and learning from your guys' mistakes, and we'll get there eventually.
Exactly.
It's not that complicated.
It's early days.
Yep.
Yeah, it's a fascinating area, yeah. Bringing
Yeah.
applications and networking together. This is a good thing, right?
Yeah, and
Especially 'cause
the token is the big thing too. When you tie a token to routing infrastructure, you tie a token to data. And so therefore you have currency and data tied together in
Yeah,
a type of system. That's the
5 minutes
power
late,
that
let's
I
get
really
started.
Hello.
Yeah.
Hello, let's start. Welcome everybody. This is the LISP working group. You can see on the main screen our note well, which you accepted when registering for this IETF. So basically you agree that whatever you say today here is a contribution to the IETF. Okay, and if you, by any chance, you know an IPR that applies to whatever we discuss here, you are supposed to tell us. Okay? The usual pointers to the various material. I'm Luigi Iannone, here's Joel Halpern, we are the co-chairs, Wasim in the front row, Padma on the second row in the front, and our secretaries will help us taking note, okay? Quick update on the status of the documents. So we have the usual introduction document has been there for a few years. We're missing just a reference, will come later on. This is actually the SEC document that came back from the ISG in order to switch it to standard track. We have the signal-free document, which is now in the RFC editor queue. So we are making progress. And we have the two BIS drafts that we hope we are close to working group last call. We will talk right after Albert will give a presentation. And Albert, when?
Yeah, that doesn't make sense to maybe I'm making a very stupid question, but does it make sense to cite the BIS documents in the intro?
The new BIS documents
Yeah.
in the intro.
Yeah.
So, but I'm not sure how much we can do that, because actually the document is in the RFC editor queue, just missing one single reference. So it's pretty far away.
It's not a good idea. Okay.
To take it, we should
No,
take it
don't let it
back.
take it off.
Well, a 100-day delays is just a 10% delay, so it's not that bad.
Don't get me started.
So the agenda for today, we will start with a point about the BIS documents. Then we have LISP GPE, the Young model, and the vendor-specific LCAF. Okay, these are working group documents. And then we have a few non-working group items we will discuss with LISP PubSub, publish, subscribe. We had to switch to presentation, actually, the map server originator SMR and the LISP control plane for ILA. Okay, so to let Tom come to attend the presentation, and then we will continue with two presentations about the ground-based LISP aeronautical telecommunication network and the corresponding BGP routing. And then Dino will give us two presentations about a decentralized LISP mapping system and an update on the mobile network. Okay, any comment on that?
This is Dino. I had a comment about the BIS documents. There was no mention about LISP-SEC, and that seems to be the only reference that the introduction document is waiting on. And that introduction document has been waiting for 1,000 days.
But
So what's the status of LISP-SEC?
Yeah, we discussed this already last time when we took the document back. The basic idea is we switch it to standard track. Well, this is pretty easy, but we make sure that is coherent with the BIS documents. So once we last call the BIS documents, we do a proofread the security document and we ship it as well.
Are you
right
saying
behind.
the introduction document's dependent on
No.
the BIS document? No, okay.
So-
Right now, it's just referencing RFC
Yeah.
6830 and
but
6330.
the idea is that LISP-SEC will reference the BIS documents.
Oh,
So,
got it.
we ship first
It's
the,
an argument for what he said.
Exactly. This has dependency, so.
If,
I mean, the LISP-SEC, from my perspective, we did a good job. If we push the BIS documents, it's just a proofread that everything is fine, and we push it as well right behind. I
Do
mean,
you
we
do
don't
you
waste
really
time.
think the BIS documents are going to move fast?
This depends also on you,
And-
huh?
No, I mean, if they're going to go to draft, proposed standard first, right?
that's all we're waiting for.
Is that all we need to get the introduction and LISP-SEC to move forward?
Yeah.
Yeah, from us as a working group, we
It
just
doesn't have to go
last
through
call,
full
and
standard.
then we hand it to Deborah, and then, I mean, the ISG now is a little bit overloaded, but they do what they can.
Well, that was the reason of the question. They're overloaded, so how long do you think it would take? You'll get it through? Okay, sounds good.
No, the issue, the problem is pulling something from the RFC editor queue to say, change the text so that there was a reference to these. It's not, we can't just change the references, we'd have to change the text, and pulling something from the RFC editor to change the text means it has to go back through working group last call, IETF last call, IESG approval. That's the problem. It's not the reference itself.
It makes sense semantically, but I understand that.
It's procedural, it's not.
I understand.
I'm glad we have professionals doing this.
So if there are no more comments, Albert, you can start.
So I'm going to give the changelog for both BIS documents. So next slide. So first for the data plane. So we had many revisions. So it's 5 since last IETF in Singapore. Actually, revision number 12 was posted today, like a few hours ago. And I'm summarizing all the changes, including number 12. Somehow I'm trying to start from more important to less important. So the first one is that we move solicit map request from the data plane to the control plane. The second one is that we went through all the routing locator reachability section and the mechanisms that are not explicitly data plane were moved to control plane, and some of them should go to an OAM document. Then we also updated the section on router locator selection, stating just that the data plane must follow what is stored on the map cache, meaning that you take into account priorities and weights and you follow that. And how you set priorities and weights is up to the control plane. Then we removed section 16, 17, and 18, which were mobility considerations, deployment considerations, and traceroute considerations. And this text must be placed in a new OAM document. And then there is a bunch of other comments. So we remove for reference to research because they don't make sense anymore, and this research has been already done. We made it compliant with 2119 and ID needs. We went through many editorial changes. You can check all the diffs. Then we moved the control plane port from the data plane to the control plane because this was plainly wrong. We also removed the PA and PI provider aggregatable and provider independent definition, since they didn't make sense because this was related to the fault-free zone scalability use case. We also, many commenters commented on the definitions, and we updated that. We also updated the text regarding encapsulation and decapsulation, regarding the DSCP field. And this is the last change for today. This was following Luigi's comments. We clarified that a new nonce is required per airlock instead of per destination. We removed the clock sweep section, which is related to how to update the EID to airlock mappings. And this text, again, should be placed on a new OEM document. And then some reference went from normative to informative. So regarding the control plane, 3 versions since last IETF. Last one was posted yesterday. So we added the control plane port into IANA because this is a control plane port. We added all the text regarding routing locator reachability from the data plane that I just mentioned that we removed. Same with solicit map request and same with airlock proving. So pretty much this is text that went from the data plane to the control plane. And then also many editorial changes that you can check the divs and different clarifications on the text and on several paragraphs that you have a list here. And that's pretty much it.
Okay. I have a quick question about OAM. Actually, when you plan to
Yeah, I wrote that.
not to put the pressure on you, but when, please.
And will the OEM document get pushed along with these two at the same time, or is it going to slow these down? No?
No, it will not. I mean,
Even though it's,
the
text has
that
not
we
changed,
are
even though it's a
moving,
new document.
There were no technical discussion on the text we are moving.
True.
It's just organization
Got it.
of the things. So
So the plan's to move all 3 documents together?
absolutely.
Okay.
Meaning that all 3, including OAM?
Yeah.
Yeah.
I don't see issue.
Okay, so let's discuss
So
OAM.
the only, because to respect the procedures, if we agree these documents are ready, we can last call this.
Okay.
But OAM, we have to call for adoption, so we'll follow slightly later. I mean, it's not, but
Okay, then we should discuss OAM. It is the right time to discuss it.
if you
Okay.
you have something to say, yes?
The question that I have is, so to me, it's a little bit hard to contextualize. So let me try to think how to express that. So let's say that we take the mobility consideration section or trace route consideration. So it is very hard for me how to fit that text into a new draft without the right contextualization. Without the right contextualization.
Do you need one? What I mean, for me, it's pretty simple. You write a 3 lines introduction that says that Lisp is defined in data plane is 30 bis, console plane 33 bis, and in this document discuss all the things that are in the middle, let's say, and management, administration, etc. Period. And you add, if you really want to be picky, the reader is supposed to be familiar with the other 2 documents.
Okay, got you.
That's it.
Then I have a problem with the expectations regarding the reader considering the title. So if I entitle a document Lisp OAM, I expect to read about the whole spectrum of what means operation and management of Lisp. And then what I found are 3 sections, which are very narrow regarding 3 different aspects. Let's say that it's mobility, trace route, and the other one. And then I feel a little bit, I have a problem with the title, really, and what people should expect regarding the title.
You have a different suggestion about the title.
I don't have any suggestion regarding the title. My problem is that, yeah, we can do that, but then the title should not be OAM.
How bad is this?
So I agree with Albert 100%. And it's hard to decide if these sections are really OAM or not. Trace route probably is, but putting the mobility section in here is totally counterintuitive. I mean, I think we should put the mobility section back in the data plane because it's a general mobility.
If I
Then
we're
going to lose the text, right?
I would never go look into a data plane document. because I would look.
Well, if you want-
either for
if you want a
something
gen-
explicit,
If you want
or-
a general description of mobility, you're not going to look in the OAM document. Arguably, you could put it in the introduction document, but
At the end,
You know-
mobility is about managing mappings. That's it.
no, mobility is about XTRs. That's part of the data plane that's moving around. And it's a general discussion that sets up for List Mobile Node,
But the consequence
List
is
Mobile
always-
Network,
the
and
consequence is always
EID
the same.
mobility.
It's not the fact that it's the XTR moving.
Hold on, Dino, you just said something that may change the question that leads me to wonder whether we need the text at all. If all it's doing is laying groundwork for the actual mobile solutions and isn't actually providing any change in normative behavior, then,
Well, it's creating expectations of what mobility is. When you
now I'm
switch,
sorry,
when
the
you
list
switch
documents
service-
don't need to worry about creating expectations about what mobility might be able to be handled by Lisp.
well,
That's,
people should read the section and make this decision.
I-
Because there was a lot of, Scott Brin put a lot of thought into writing that text. And I don't think we should lose it because people have different expectations of what mobility is. Changing service providers is a mobility event that happens once a year possibly versus being on a high-speed train, changing your outlooks. And that needs to be set up somewhere so people knows that List Mobile Node's trying to solve the train problem and regular multi-homing document and the deployment specs are trying to solve the service provider problem.
I agree, but I mean, nobody wants to lose the text. Nobody.
Okay, good. So where do we put it?
It's just a matter to be clean in the structure of the whole document set.
Yeah,
And,
okay, good.
Maybe there is no perfect solution, but for sure, I wouldn't put mobility in a data plane document, okay? Because it's not data plane, it's something more.
You're suggesting it's better in the OAM than it is in the data plane?
So we can discuss, it's OIM the right title. Let me think a little bit about it. Maybe not. Maybe for me, I'm not shocked about using OIM as a title, to be honest.
We should
Because
ask the
it's where-
we should ask the working group on the list and see what people
Yeah,
think.
sure,
right?
sure. Good.
I mean, it may be that we want a different title. That's a very fair concern, yes.
A proposal for, this is Fabio, proposal for title could be consideration for list deployment, mobility, and trace route. That's pretty decent title.
It makes more sense of this.
That's fine.
There is a deployment draft, but that's a different story.
Considerations, it's deployment considerations, right? We have to check, but yeah. But we will try not to overlap in the title, but
So-
makes sense.
If we have if we agree somehow that the title OIM is a little bit not very clear, and we go through a different title, then I volunteer to write that.
What we can do is this afternoon, I sent an email on the mailing list stating that we should. There are concerns about the name. The one discussed right now
Okay.
is something around mobility, deployment, and trace route consideration. Anybody complains, anybody has a different suggestion. And by the end of the week, having a decision, what do you think?
Okay.
Is the room happy about this? Okay.
That's the measure, yes. Next.
Thank you. Thanks, Abby.
So I'm
Bleed through from Buckingham is bad.
Should work.
okay.
Here we go.
Great. Fabio Maino presenting about LISP-GPE, draft IETF LISP-GPE 00. So this is the status, very quick status update. There is a list of editorial changes that were sent thanks by Luigi, and those are being introduced in version 01. There is one technical comment open that also came from Luigi and I think Dino's comment about backward compatibility. So I have two slides, the next two slides, proposing how to address that. And the idea is to use the same logic that are used for RFC 8061, the script. And also on status update, I just wanted to just let the working group know that there are two implementations of LISP-GPE that are open source in FDIO and OOR. So here is the idea on the proposal. So the problem is how to handle the case where there is a mixed deployment and some of the router are Lisp router and some of the router are LISP-GP router, LISP-GP capable router. So looking at it, it seems to me that this is exactly the same problem that Lisp crypto is addressing, right? So when we basically send a Lisp encrypted packet in a network, the receiving router may or may not be capable to understand the packet. So in Lisp crypto, what happened is that because of the negotiation of the Security Association, the ITR knows that the ETR is capable to receive the encrypted packet. So it seems to me that this is the same problem here. If we have a way for the ETR to signal the capability to the ITR that it will be capable to receive GPE extensions, then we are done. And so the proposal is basically what Dino was suggesting and say, let's add one bit to the multiple data plane LCAF, and that bit is basically saying that the ETR is capable to receive GPE extension, and that's it. And so that's pretty much a very simple extension. This is RFC 8060, so probably I think that from an editorial point of view, the Lisp GPE draft will basically request to address a new bit in that LCAF. The question that Dino raised was, do we need a different bit for VXLAN and Lisp GPE? I think so, because with Lisp GPE we want to preserve the additional Lisp features that we have in the GPE extensions. This is the text that we have today that we want to basically change. And here, I don't know, some comments I've heard this morning when I shared the slides with Alberto, he was pointing out that this may be even a little bit too tight, because really, here what I'm saying is that the ETR has to explicitly acknowledge the capability. And I'm saying that the multiple data plane LCAF type has to be used. There may be deployments where maybe one can do static configuration or things. So maybe trying to soften the language a little bit there, but saying that the ETR can the ITR can basically check for support for multiple data planes and use it.
Yeah, just to clarify, this is Alberto. Just to clarify what Fabio is saying right now, my point here was that we should definitely use the multiple data plane LCAF to detect or to be sure if the XTR on the other end supports this or not. But that's something that we don't need to use if we know for sure via configuration or other means that the GPE is supported, right? So for cases that when we are not sure, we can use the LCAF. For other cases, we can avoid that completely. Right. So, yeah.
And that, I think a better language can be used here to express that that intent.
I like this language, but I agree that by configuration, or you can have other means. So to add something,
exactly. Or by other means of static configuration, or maybe you're running a network where there is only Lisp GPE, right? So you actually don't need to do anything special. So
I have another question, but let's go to the other slide first.
I think I'm done. So I think if we agree on this direction, the next steps are we need to allocate a G-bit in that LCAF type, and I think this can be done in the YANA consideration of this draft. I need to update section 4 to address what we discussed, include Luigi's editorial comments, publish a new version, and I think that then if everybody's happy, and it maybe propose Lisp GPE for Let's Go.
I have a clarification question. Now, with this G-bit, okay, you have a way to understand whether or not another RLOC supports GPE.
Right.
Now, assuming if it's not, okay, you use, let's say, legacy Lisp, vanilla Lisp, or whatever you call it. If it supports GPE, how do you deal with the nonsense versioning? You want to keep it the way it is, that to shrink? Yeah. Okay, just to know.
Because now I know that there is a capability, so I can use the shorted version of nonsense versioning, and that's it.
To add to a comment based on what you just said, if the encapsulation type's returned by the ETR, all the data planes that's supported by it, well, all those bits will be set. So you don't have to say if the G bit is not set, and if that encapsulation type comes, you use one of the other data planes. You don't have to say use the default. The only time you use the default from 6830 is when this LCAF is not returned, because you have no information about any data planes except the default one, right? That's all.
Well, or presumably if there's not a match between the ones supported on each end.
Okay, well, good point. We should maybe check to see if the text says that, yeah. So related to the same point, since we have to change it to add the G bit, should we take an inventory of all the popular data planes, like maybe add the I bit for ILA, since it's becoming fashionable now or whatever?
It's not yet there.
No, it's not there. And then the question is, should we get rid of the ones that we think have already failed? But
in any case, to do that, I think each individual draft that is proposing a different data plane will have to take care of that, right? Like this one for GPE is doing that. There is an ILA draft, and maybe the ILA draft should basically propose that.
Yeah, and that's just fine. But I'm just wondering, because we're going to have to change the LCAF document, so maybe we just want to change it once and or start the registry process, right?
Okay.
Luigi?
Why do we? Oh, because we want to do from experimental to standard. But that will take time anyway, right?
So we're going to, each of the use case documents will say, I need a bit. That's fine. You go ask the registry, but then we have to, do we just keep a document in the use case documents? And then the LCAP document doesn't specify the bit. So we have to.
Yeah, I would say that every document requests the bits. And now we can add
That's
something in
simpler.
the IANA consideration that the IANA supervise that no two documents
So
ask for the
it's
same
simpler
bit.
that way.
So, and we will start that process or something that makes sure that there is no conflict. But
Right.
I think.
Okay, I think that's all for me.
Okay, so the document is pretty small, I would say. So there are just few things you have to fix.
Yeah, it's very short. Yeah.
So for the last call, we should have the new version of the document, but we can sense the room if there is
okay.
But then we will proceed with a last call on the mailing list. Okay, so assuming all these changes will be done, okay. If you agree, it's time to go for a working group last call and this document is done, please hum now. Thank you. If you have any objection and you think this document is not ready, please hum now. So silence for the record seems there is consensus. So we will wait 01 and then we go for last call on the mailing list. Okay? Thanks. The model.
Okay, my name's Rashad, and it's a quick update on what's changed in the Yang model since last time. So one of the versions, I think between 05 and 07 was just a refresh, but so the changes are mostly minor to comply with 6087 BIS. For those who are not aware, that 6087 BIS draft is basically the guideline for how Yang drafts should be written. We've added some text, we've changed some copyright information and stuff like that, so nothing really major. And in terms of the Yang itself, the only change really was changing some counters from 32 bits to 64 bits. We need to do quite a few more changes. So the security consideration section is pretty empty right now. That's very important. We need to change to Yang version 1.1. The Yang itself will not change because of that. And also we're going to be adding a few XML examples which will validate using Yang lint. Also, right now, the way the model is, the Lisp is at the top of the tree, and the guidelines is to have Lisp as a control plane protocol, so we'll have a new identity, and we're going to augment the control plane protocol's existing model, which is being modified in 8022 bis right now. And also, we've done a comparison with some of the data which is in the LISP-MIB, RFC 7052, and we've noticed that there are a few things which are missing in the Yang model. The major things are the three things identified here. For example, we don't have anything to map a VNI to a VRF. The MIB has an IID to VRF table. We don't have any leaf nodes to explain what the map, to identify what the map cache limit and map cache size are. And also we're missing timestamps for stuff like what was the first registration and the last registration for any ID. So those three things are things which are in the MIB right now.
Real quick question, this is Dino. Do we have to have an IID to VRF table mapping? Could we have an IID to interface mapping and the VRF is implied from the interface, be it logical or physical? And does that help with this, or?
I'm trying to see how ID maps to one interface. Maybe I'm missing.
Usually VRFs are configured on interfaces, physical or virtual. So if IIDs are just done in the parallel way, you can infer from the other.
But the ID will map to multiple interfaces, not just to one, right?
Each interface is assigned a VRF, right?
Yes. But,
So you map an IID to each interface, and because there's never a many-to-one relationship between VRF and interface. It's always one-to-one. So the one-to-one relationship maps for all three
but
types.
many interfaces can belong to the same VRF, right?
Say again?
So many interfaces can belong to the same VRF.
Yes.
So how would you map to one? Okay, which interface would you choose out of your many?
No, when a packet's received on an interface,
Yes.
you know what IID it is, so you know what to map request and map reply. On decapsulation,
Yep.
you decapsulate and you get the instant ID from, you're saying on decapsulation, the instance ID, you have to know what, you have to know what routing table to look up to find the interface.
Yes.
Oh, so it's on the decap side. Got it. Okay, sorry about that.
And this is it.
Any other comments?
So also, we've been a bit slow in updating the Yang model. So the plan is to...
I was asking this. Go ahead.
The plan is to do those updates fairly soon, not wait until beginning of July.
Okay.
That's the plan.
Excellent. Thanks.
I'm not signing in blood.
Okay.
I can take some of the blame on the Yang delay as well. So Rizal doesn't need to be alone on that.
We know Spanish are always late.
Yeah, we are always lazy. So, okay. The vendor-specific aircraft. So this is one draft that has been progressing pretty quiet through the working group, which is a surprise for me. So this is a short story of the draft. Basically, we submitted in July last year. We adopted as a working group document in August, and many people commented on the list supporting the document. And it's a quite straightforward extension to aircraft. So no technical changes have been introduced into the document since the original submission. We have some internal testing on this at Cisco. But basically, if you take a look at the draft, actually thanks Luigi for the editorial review you did. That was good. If you take a look at the draft, you'll see that it's just defining a new aircraft type that shouldn't be any problem at all. So we would like to see if there is support on the working group to move this to last call, because we don't see any other work that needs to be done on this document.
Just to clarify on my review, there are three comments I think totally editorial. Okay, so there is there will be a new version of the document, but technically 0 changes. Now, like for the other document, we can test today for look for consensus and then make the last call on the mailing list with the new version of the document.
That sounds good.
Okay, so concerning Windows-specific LCAF, if you think that this document is ready to be published, okay, please now. Okay, some noise. If there is any objection and you don't think the document is ready, please now. So silence. So it seems there is consensus to move it forward for the last call. Thinner. More energy, please, in the room. So, but
I'm not sure we can try consensus conclusion, but the conclusion will be called on the list. So, but guys, if you want this done, we're going to need to hear from people on the list. Silence means we don't advance things.
The humming is proportional to the length of the document.
Make sense? So we will wait for the new version of the document and then ask on the mailing list. Moving forward.
Okay, so another quick update. This is for PubSub. We are now in version 02. In this one, we have gone through a few different changes. So it's not that straightforward, but almost. We submitted in August last year. In October, we did a revision with some comments that we got from people that look at the document. Nothing major. In the IETF, we present this. We got a comment from Eric Norman on the nonce on the notify, and we have updated the document to reflect that. And we would like to highlight that this document is now being referenced by 4 documents. One of them is RFC CT33bis, which is one of the important documents. And we have running code in Lisp.net thanks to Dino, and the guys in the OpenAPI router implementation, they're also working on that as we speak. So the question that we have is if we should adopt this as a working group item.
Any comment from the room on the document? No? Okay.
Just one generic comment. PubSub is used in the iCloud draft that we will talk later, and so that is kind of one use case that is driving adoption of this PubSub feature.
Okay. Okay. Let's see if there is energy in the room. Okay. So the autos are, Dino, you have a comment?
One comment for support. The signal-free multicast stuff can make use of PubSub as well, especially when we're using star comma G trees, because what we do now is we notify SG by looking up the S in the mapping system to find the ITRs. But if who we need to notify is not where S is, then so that I think, Victor, that's going to make star comma G work better.
Right. Thanks, Dino.
Okay. So if you think this is interesting work and this document should be adopted by the working group to work on it and later on hopefully push it for publication, please hum now. You are improving, there was noise. So if there is any objection and you don't think the working group should work on this item, please hum now. Silence. So this time was clearer. There is consensus to adopt the document. We will take it to the mailing list.
Thank you. A lot of presentation from me today. Okay, so this one is a bit more interesting. This is a draft that we did a long time ago before the PubSub document. And now, as we just saw, it seems that there is some consensus of the working group to move forward with PubSub. but this document, the MS originated SMRs, is documenting what is implemented right now in Open Daylight, in an open source controller that is implementing Lisp, and is well used in several SDN deployments. So the question now is, we want to move forward with PubSub, but this is being used actively right now. So there is, well, it has been in running code and in production for some time now, and it's been used to kind of have a PubSub-like support with vanilla XTRs. So we don't think that this should move to the working group because PubSub is what the working group should focus on, I believe. But how shall we handle this? Because it's documenting Lisp running code. So maybe one way to close the document is to move it to informational. So I would like to see the opinion on the working group on this.
Yeah, just one comment. The point of this draft is that it doesn't require changes to XTRs as defined by Lisp RFC 6830. So that was why it was implemented in this way, I don't know, 2-3 years ago. And the documentation was done because there is a public implementation of Open Daylight, so people were asking, hey, how do you implement this feature? So yeah, I definitely support what Alberto is saying, right? We want to move forward with PubSub, and future implementation will deal with PubSub as specified in the other draft. I think, just to leave this as a document, we can make this informational and leave it there for future generation that want to PubSub.
So a quick comment. I mean, making the document informational doesn't solve the problem on whether or not the working group should work on it. Just informational doesn't mean. Now, having said that, the one easy way to make it informational without the working group working on it is individual submission. Then you push it as an individual submission to the RFC editor. The editor will ask us, the chairs, to what we think about the document, and then can be published and will stay around as it is. With the reason is there is implementation, so we want just to inform the community that there is this implementation in this way. But the way to go is subscribe.
Yeah, that's exactly the kind of discussion we hoped with this, to see if there was any comment from the working group.
Yeah, please, the comment. Any comment is welcome. Dino?
This is Dino. Does the document suggest that this was an experiment and that it suggests to use the PubSub as a solution?
That's a good point. It doesn't, but we could include that.
Okay.
I think that's a good point. Yeah, I think it's a good point. Thanks, Dino. Okay, so that's it.
Okay.
And to make it individual, what do we need to do? We publish individual?
So let's separate. There's two different things. There's informational and individual. As informational, there's some technical things that need to be tweaked and put in the reference, the other pointer, and the working group could publish an informational document that clearly says this is not the preferred solution, but it is the more compatible one. So for transition, you can do this. For individual, the working group has no say. We'll be asked, is this a competitor? And as long as it says explicitly, this is the not preferred option, but it's published for information, you can publish things as individual drafts. That's a different, they will also be informational, but that's the independent submission path, and that's a different game. What I thought was being asked about was for the working group to work on this as an informational document.
So a question for the chairs. What do you guys think is the best way to move this forward, based on what you just saw on the slide?
Well, I looked at the document while you were talking to refresh my memory of it, and I think there's some things that need, if you want to move this forward, there are things that need to be said about how the map servers will know who to send this information to, because there's some state assumptions that are implicit that need to be made explicit. But if you do that, I have no problem with the kind of clear statement that was just discussed with the working group publishing it, and I would therefore prefer to see us work on it so it's a good document from the working group about steps along the way.
Okay, thanks. That makes sense to me. Okay. This is the last one for me, I promise. So this is the most interesting one out of the board. This is a document that we just published for the IETF that talks about how you can use the LISP control plane with an ILA data plane. As you all know, with the split with the BIS, the RFCs, and so on, now the control plane and data plane are separated, and nothing prevents us. And actually, it's been used for other data planes in some implementation. Nothing prevents us from using the LISP control plane with any data plane of our church. So this is not introducing any modifications in either the LISP or the ILA architectures, but rather discussing how you would use the LISP control plane when you have an ILA data plane in place. I don't see Tom here, but it would be good if he can join before we finish, so he can comment as well. So basically, and I'm not working actively in ILA besides this draft. So if you have questions on ILA, you probably can refer to Tom. There is above on Thursday evening. You can attend if you have interest. This is only focusing on the LISP control plane specific aspects for ILA. So ILA, for those of you that are not aware, is a data plane that follows the ID lock split philosophy, but instead of doing encapsulation, it's doing address transformation. So if you take an IPv6 address and you split it in two, one part is going to be the locator, the other part is going to be the identifier. While the locator may change, the identifier is going to remain. So the same idea as with other ID lock splits, but this time using IPv6 addresses and doing everything inside the single IPv6 address. So another point is that in the draft that is right now uploaded, we are using that version of the ILA. Can you use it? That version of ILA that is on the Internet Area group. And Tom just submitted one right before the IETF that we were not using while writing our document, but the spec is basically the same. The new version, the ILA 01, is just covering some stuff on /64 and some mobility. So that's kind of the same thing. These slides, I took them from the presentation that Tom did at Singapore. Just to illustrate ILA for those unaware. Again, if you have any particular question or you want to learn more about ILA, you can refer to him. But you can see here the concept of keeping the identifier static and then changing the locator. So in ILA, there is the concept of SIR, a standard identifier representation, which is what endpoints would use. So in our LISP world, this will be kind of in the EAD space, and this will be in the LOC space. So devices on the EAD space will be using the SIR. And again, this is the general case. In ILA, there are some exceptions, and different use cases may use different ways of doing things. But talking about the general use case. And then when the packet has to leave the EAD space and traverse the LOC space, the SIR part, the EAD part of it will be replaced with the locator part that is routable on the underlay and so on. Well, actually, in ILA, the SIR is also routable on the underlay, but that's another story. This is a topology that Tom used to represent the ILA infrastructure. So there are a few components that we could try to map to list the different devices you wish. Basically, you have the ILA node that is where the host attached to. You also have the ILA host that is running like the equivalent of nodes, but within itself. So let's say that this could be a VM in a data center that has some containers that are on the EAD space, and then before they leave the host, they are already translated into ILA traffic. This could be, I don't know, endpoints, mobile phones attached to an antenna in a 3GPP network, and then you have the ILA routers that are the devices that serve in a canonical ILA infrastructure to translate the EAD to a local space if no one has done that before in the past. So now talking a bit of the roles of the different LISP devices in this scenario where you have both ILA and LISP. This is using some of the ILA terminology, but this is not proposing or defining any change on Lisp. So an MSMR is a Lisp MSMR, and nothing new that needs to be done for ILA. But basically to put things in context and where you have both things, which device does what. So the MSMR, as you can imagine, is storing the mappings, the identified locator mappings. For the domain, or as in ILA, they say for the shard, which is basically a subset, so you split the mappings across different devices. And then the ILA router is supposed to have a complete map cache for all the mappings in the domain. And in the case that you use Lisp, in order to explain this in these terms, you can say that you subscribe to the MSMR to get all those mappings, or to complete your map cache, or the MSMR and ILA router are co-located, so the ILA router has access to all the mappings. Another thing that ILA router does, and this is something from ILA in general, regardless of Lisp, is that it announces, or they announce, the share prefix into the underlay. So if an ILA node is not able to translate a packet into ILA, it can just forward the share packet into the underlay, and it will be attracted to an ILA router that will translate. And it's serving as a default path for data packets, I was saying. So if you don't have a mapping, you can always forward the non-translated packet into the underlay, and an ILA router will take care of that. Then the ILA node, for the purpose of this draft, we assume that it has an incomplete map cache, and that this is populated on demand. We will discuss a bit later on how you can do that. And we assume that it doesn't matter that much, but just to have a clear picture, the ILA node is supposed to be the one having the endpoints. And for this draft, we use ILA node or ILA host as interchangeable. So we just say ILA node. So it doesn't matter that much for us if the endpoints are directly within the ILA node or are attached outside. And we assume that the ILA router will not have endpoints, but again, this is just for clarifying the explanation, and it's not a constraint of the architecture or the protocols. So the only thing that we are kind of introducing here, which is not changing the architecture at all, and actually something that we would like to discuss with the working group, is that we propose a new LCAF type to represent the identifier, the locator, and the share prefixes on ILA. And within that LCAF, we have 3 subtypes to go for each of these. And the reason we use a explicit LCAF type for this is to be explicit on the length, because in ILA, it's not the identifier and locator length is not fixed. So usually you have a split by the middle, so 64-64, but that's not a requirement of the architecture, so you can have different lengths. In the images on the right, I put an identifier and a locator like in the most common form, but the length again is not fixed, so you don't need to look at the bits here, because this is just to represent this particular example, but this can be any number of bits. Same here. So we use explicit LCAF types to have a explicit length. Also, to give this explicit meaning on the mapping system. So if you have this LCAF as an ED or airlock on the mapping system, you know that this is to be used in LCAF devices. And also to add some metadata bits that on the draft we use both in the identified side and in the locator side. One comment that we got on the list, for instance, was that we could use IPv6, just IPv6 for this, which I completely agree. The question then is, you may run along the way into some troubles if you start having deployments where you may have different locator lengths, or when ILA may be only part of the infrastructure, but you have some other data planes and you are using the Lisp control plane to manage them all, or if you have some bits that you require and that the deployment needs, so you cannot allocate those directly in IPv6. Also, in using IPv6 addresses without any LCAF, then we need to discuss what do we return as in the locator, because the locator is only the upper part, so you can send the share address to the mapping system and then return the locator with the either identifier or there are other options. I see Dino there because he already implemented this on his mapping system. Do you want to comment on this part in particular? Okay, go for it, Dino.
So you're saying being explicit that it's an ILA address is important because you may have multiple uses of an IPv6 address. But I would say an ILA system is going to look up something and probably be configured with a SIR prefix. So it's going to know what it gets back is going to match that. There's a good chance that a Lisp XTR may want to look up either a SIR prefix or an IPv6 to get a locator because maybe ILA is running over a Lisp overlay as well. So I think depending on who does the lookup, they know how they're going to use the information. And the lookup comes from different sources. So I don't know if you need to distinguish it unless there's explicit ILA functionality that has to be conveyed with the address.
So
and that's what I thought your comment on the mailing list was, is that there's specific information, but I don't know what it is. Do you know what it is?
Two things there.
Okay.
Two things there. First, I do agree with what you are saying. So I'm not against using IPv6 here. My point was, if we start deploying this and we start, this grows organically as it goes along the line, we may start seeing places where it's not that clear. And even if someone is asking and you know who is asking, maybe those guys are serving different deployments at the same time. So that could be a reason for concern on the road. And regarding the explicit ILA metadata, let's say, in the draft, we have two bits there. Others may appear, in particular, for instance, the one we have identified is to distinguish the identifier when you are doing ID log mapping resolution or when you are trying to resolve the endpoint address to the identifier, because there are some cases in ILA where the address that you use and I'm sure that you are aware of that, the address that you use as an identifier through the network is not the address that the endpoint uses. So in this case, the endpoint is using the standard identifier representation address. And this is the one that ILA understands and can translate. In other cases, you may have different addresses and then need to be mapped in some sort of this. So there's kind of a two-step process that you can combine into one. And to distinguish those lookups, you use that, for instance. That's one example. And in the locator, the bit that we use there is, as you may know, ILA is doing some smart trick regarding the checksums, so you don't need to recompute the checksums in some scenarios. And
you mean that has to be conveyed with the mapping?
That's one option. So this is up for discussion. So the remote XTR can tell the other guy, hey, look, I don't need you to recompute or to do the adjustment of the checksum because I know that in the underlay, no one is going to drop this packet and I am being able to understand it, right? So you may prefer to say to the other guy, don't waste your resources on doing the adjustment of the checksum because...
What did Tom think about this feature?
I don't know, because we would like Tom to be here.
It sounds like it's a gratuitous feature.
Discuss.
Okay.
But this is a 0-0 draft, so I'm not expecting this to be final by any means. So this is good. This is the kind of discussion that we're hoping with this draft.
May I ask something? So the two solutions are not mutually exclusive, right?
They are not, no.
So I didn't read yet the draft, but I mean, everything could be documented and with discussion like you are doing that says, look, if you are in some scenarios, IPv6 is okay. It's enough. You don't need more. But if you need more for a list of reasons or because you are a certain class of scenarios, here it's what you can do with LCAF.
Right.
So, I mean,
I kind of agree with that view as well. I think for the next iteration of this draft,
I don't agree with that because if you give too many options to the implementer, they're going to wonder why it's needed. And if they don't do this special use case, which is not yet defined, they're going to say, do I need it? And then you're going to have interoperability problems because some vendors are going to support only IPv6, some are going to support the other one, some are going to support both, and we're going to have to add another encapsulation type to the
But what you're saying is that if needed, we can do that, like this special LCAF in the future for those use cases and add that to the draft because...
So why don't we create it when the requirement comes rather than now and guess what the future requirement's going to be?
That's fair as well.
Mm-hmm.
But
maybe Tom has features that he wants to convey in the mapping where this is going to be useful, but we just need to get an authoritative source to tell us that, right?
So this is our understanding of ILA use case and so on, and things that we see useful here. But I completely agree that Ton can comment on particularly this part on the.
But this C bit is nowhere in his architecture now. He doesn't need,
No,
Yeah.
it's not explicit. So no, the CBIT of course is not.
okay.
But what the draft says is that you may need or not need to do the checksum adjustment, right? So the CBIT is conveying that in the control plane. So that instead of saying, okay, this guy is configured to do the adjustment or not,
Yeah.
you can carry that information on the mapping system. So next STR can register that into the mapping system, and other STRs trying to communicate with it can use that.
But it's not the hops along the way that have to recalculate the checksums. It's the ILA end nodes, and they already do it within the protocol before they do the transformation,
Yeah,
right?
but that's my point, that it's not mandatory that they do it. So they can do it, but if they are configured to not do it, they don't need to do it.
I thought it was required because it's gonna, you think they don't need to do it because the SIR prefix will be on the source, and before the transport gets it on the destination,
So
it'll-
if you have control end-to-end on the underline, let's say, and you know that the packet can traverse fine from end to end, you don't need to do it because it's not, no one is gonna.
First of all, it's a transport layer checksum, not an IP header checksum. So the underlay is not even involved in this.
No, but
That's-
the adjustment you do it on the IP address, right?
Yes.
So the point is that.
And IPv6 doesn't have a checksum in its header, so hop by hop doesn't even have to consider this as an option. It's only before you hand the packet to TCP on the and to the transport layer on the destination, that's all.
Right.
So it's a pseudo header checksum for the transport layer, that's all.
So the way I see this is that this could be so it doesn't need to be mandatory, but again, this is a draft that is up to discussion. So if people deploying ILA consider this to be a requirement, a mandatory, then we can remove that.
Yeah, of course.
That's fine. Okay, so more stuff here. The mapping resolution part, as I was saying before, we see two places where lists can be held, can be used and held in the ILA resolution. The basic one is when you need to resolve an identifier, so you need to find the locator for the identifier, and that's the part on the left. And then another case that we see is that sometimes, as I was saying, there are use cases in ILA where you don't need, where you don't have directly the identifier that they're going to use to resolve and to get the locator. So you may need to do a pre-translation on for the identifier. So in those cases, you can use Lisp as well to ask for the identifier, and along the way you can get the locators as well. So you either do this as a two-step process, or you collide everything into a single step. Then, how the signaling looks like when using the ILA data plane. And I describe here two cases. This is the standard Lisp way of doing things. The next one is something that we have been discussing on the list, that is how ILA also considers doing things. But basically, how would you do is, you have an ILN node that is trying to send traffic to another ILN node. You need to resolve the mapping for that. So using a map request, you get a map reply. Now, meanwhile, and that's why we have this dotted line here, the ILN node can send the served traffic to the underlay. The ILA router is announcing as any cache the served prefix, so it can attract the traffic and translate it while the ILN node on the left is retrieving the map. Another option is to cache the traffic here, to drop it, as we are used with Lisp. So different options on how to do while this is being resolved. Now, once the mapping is on the ILN node on the left, it can directly itself encapsulate the traffic from one ILN node to the other. Okay. And as you see, the map server here and the ILA router has nothing to do with each other, besides that they are helping to make this work. Now, in this other case, which is something that for instance, Tom is discussing on the list with us, is that you have you prefer that instead of resolving the mappings on the ILN node by doing map request map reply, you directly send the traffic to the underlay, so the ILA router will catch it, and then when it sees a packet, that is not being translated, it sends a message back to the ILN node. In Lisp, this message will be a map notify, and again, this could be discussed here. But this, for instance, this is already supported in PubSub to send map notifies to guys as long as the configuration of both allows to do so.
May I?
Sure, go for it.
A quick comment. I'm not sure, I'll have to check, but in 33 bis, at some point we say that an XTR should drop any unsolicited map notify.
We are maybe changing that on PubSub because we have explicit test that says that if the configuration allows it, so that you need explicit configuration, an XTR may accept.
So I don't mean you cannot do it.
Correct.
You have to be clear that that goes against the specific, not against, is relaxing the.
Let me try to phrase what you're saying. It's not documented on RFC 6833 bis, but it's documented on Lisp PubSub.
Stronger. We have to check, but because in 6833 bis, at some point, I have to check because my memory.
No worries,
but we say that any map notify that is not solicited by map registration should be dropped.
Mm-hmm.
Now, here you are going against that should.
Right.
So.
And in the draft, we're referring to PubSub where we extend 6833 bis.
Okay. You allow this.
Luigi, that text doesn't exist because a map notify was originally developed to notify, and it was also overloaded to be an ACK. We decided we could use it as an ACK at the same time. So there's no such, yes, it is an unsolicited map notify, but it has to be because you want to be informed when something changes. So Signal Free uses it, PubSub uses it, and then being an ACK to map register is just a bonus, I guess, right?
So that's it. About deployment considerations. Another discussion that is ongoing is the use of UDP versus TCP. And as you guys here in the working know, Lisp by default goes over UDP, but nothing prevents you to run it over TCP. And actually, there is a explicit specification on reliable transport for Lisp that if you have a reliable transport in place, you can leverage on some features that are defined on that draft. The another point is what we were discussing a bit before on the ILA router and map resolver collocation. So if you have that, and since the ILA router is supposed to know all the mappings in the domain or in the stack, you don't need to subscribe the ILA router to the MSMR. Another option that you can do, these are most of them, they are options or points for discussion, is that you can push towards the destination ILA node the mapping when you see someone requesting that mapping. I mean the source mapping, so the destination mapping can have the source already available when the traffic goes back. Then what happens if you have multiple ILA domains in the same map server, and that applies to the discussion we're having of the share prefix and so on. And then we were discussing on the bit as well, if you want to have this adjustment per locator of its mandatory levels. And I think that's, this is the slide from Dean on the implementation that he did on his map server, so you can see that ILA can coexist with the rest of the Lisp infrastructure. And I think that's it. So go for, I see Tom there. Hey, so excellent.
You want to say something?
Hi, Tom Herbert. Sorry, I'm late. I had a couple questions. So TCP versus UDP.
Mm-hmm.
I'm not entirely familiar with how that works in Lisp. I have some ideas for ILA. When you're using UDP, is there some sort of state that says which map servers might send you a map notifier, or would you accept a map notify from any map server? There must be some security there, right?
So
because TCP, I would just have connections open up
mm-hmm.
to whichever map servers I wish to use, right?
Mm-hmm. Right.
My first comment is Tom has a requirement for iLAMP to run TLS over TCP. So we have to make sure that if our TCP draft has security in it, number one. right? And then to address his issue is, if you care about a mapping, any map servers locators can change, and therefore any map server can give you a map notify. And the map notify that's sent is sent with a unique nonce, but there's no authentication of it right now. We can extend the ECDCA draft to say that map notifies can be signed, and then the receiver of the map notify does a map lookup in the mapping system to get the public key to verify the map notify. So I don't know if you think that satisfies your concern.
Yeah, there are different ways to do that, as Dino was saying. So those are points for discussion, and we can add or discuss on several iterations on this. So that's fine.
Okay, so I think that's a good introduction. Let me generalize that a little bit. So UDP is the predominant use case today, or is it TCP?
In LISP, you mean?
Yeah.
But I guess that question depends on your deployment. So you can use either of them.
Well,
in practice, that's also a good question, because we see deployments with both.
okay, so like Dino was saying, for ILA, if we go with we have a lot of redirects, it does become the issue of security, and having that TCP connection gives us that much benefit. The other part about TCP that I suggested, and I know there may be some implementation in LISP, but using something like REST and just upping the whole control plane to look more like a data center type of API controlled protocol as opposed to a low-level routing protocol. So maybe just things to think about.
No, and
I don't think any of that affects the primary packet format or things like that. But I am concerned about the security, especially of UDP. I will say that.
No, that's perfectly. That's good feedback. And all those details we can discuss, because at the end it's what people deploying this may care about. So those are details that we should discuss on the draft as well. Yeah.
So a question for the working group is, if there is a REST interface is done, is that an implementation that's done, or does the working group have to specify how it's used?
So Open Daylight has a REST API for LISP that you can use right now. It's following like our best.
But that has nothing to do with the IETF, right?
As far as I know,
And should the IETF get involved in defining RESTful interfaces? I don't know.
That I don't know either.
So, I mean, it could be made available, but your favorite vendor or open source will do it, right?
How would you make it interoperable?
Well, okay, so question to the working group,
Yeah,
how do we get
this
interoperable REST implementations?
Yeah.
And should this working group or any IETF working group do that, Deborah?
Probably the point is that it will certainly help adoption, right? In the sense that if you have a REST API for the mapping system, I guess that for the typical developer of ILA application, it will be easily to use, right? I mean, they will be drawn to probably use a REST API rather than having to deal with.
I think that the question is what Dino asked, is like, shall the IETF be involved into this, or do we need a standardized kind of REST API for LISP? That's the question I have.
Well, but I want something that's standardized, right? Obviously.
So then the answer may be yes.
So I'm perfectly happy. I mean, the LISP control plane seems functionally complete. But trying to map that into the broadest use case, I think if we could get it over REST, that would be quite helpful.
Oh,
I think the difference between UDP and TCP, this day and age, I'm just seeing a lot of use cases for TCP. This really isn't a routing protocol anymore. It's more like a database, and I think matching that might be helpful.
Completely agree. Yeah. But just to refresh what I said, we see deployments in production using both UDP and TCP.
Right.
So we are aware of both cases being deployed and used in the industry right now.
And I think the driver for TCP, at least from what I can tell, more than security has been the size of the mapping. So whenever the size of the mapping is big, rather than having a lot of UDP requests, having a TCP section and make it a little more reliable. So
okay, so what does size of the mapping mean? Because I did look at some of the LISP formats, and they were a little bit verbose. So is there a way to That would be kind of a side question. Can we compress that a bit?
If you put a lot of metadata in the mapping, I mean, because that can grow depending on the application.
Kalyani Bognini, Verizon. My comments are related to the ILA mapping system tied into the 5G system. There, the 3GPP is working on the APIs for the services-based architecture. If the mapping system has to be used in the context of the 5G system, I think the framework for those could be reused from what 3GPP has.
Thanks, that's a good comment, yeah.
And to follow up to what Kalyani was saying, I think what is emerging from the conversation in the DMM working group with regard to support for mobility is that, and it was one of the goals of writing this draft, right? So I think, and that was clear, I think, inside the working group, because we did the separation of 6830 and 6830 bits exactly with the intention of having a control plane and various data plane. So what I'm observing is that I think now times are more mature, and people even outside of this group are looking at LISP to play that role, right? And the DMM work for 3GPP, I think, is a great place, because it's basically showing that you can have a LISP control plane there that can support mobility for ILA. One example, and that, we just pick ILA because, we like Tom, and he's very vocal in supporting it, so it's a very good source for learning about it. But, you can pick pretty much any other non-tunnel location separation protocol and apply to it, right? I'm thinking to SRv6 or, whatever other data plane that is proposed in DMM probably works with support for LISP.
I just had a comment question regarding the REST APIs. Isn't the issue just you have netconf and RESTconf, you have a Yang OK model, which is OK standard, and the job is done, or do you need more?
I would look at the rest for the rest part.
I'm sorry?
The rest for the rest part.
Okay.
So it's standardized through the netconf.
Well, netconf is a standard, RESTconf is a
Can you all
standard.
speak to the mic?
And if the Yang gets standardized, then you've got your data model and your protocols, which are all standard. So I think you're good.
Hi, Padma. I had a comment about, piggying back on what Kalyani said about the placement of the mapping system in the 5G. I would encourage you guys to look. There is a document that we have published in another SDO, which actually explains very clearly all the interactions between the MME and all the 5G architecture. And actually, I would like to discuss with you guys and actually make sure that we ensure that all this work can be leveraged.
Yeah.
It's already there. So I think Kalyani is actually referencing that. And actually, I would like to work with you guys more on that.
Excellent, great.
If you want to spread the read of this document, why don't you send a pointer on the mailing list where we can find the document?
So one comment on applicability. I agree that it would be nice to have one mapping system that could cover all use cases. One thing that I would point out, if, for instance, you're using a mapping system within a closed network versus using a mapping system in a public mobile network, privacy, security, denial of service are very, very different. And I think I raised that issue on the list, especially denial of service. That's going to be a tricky one. So we know that whenever you have a cache, for instance, so we know we need a cache to scale in most of these mapping systems. That's going to be a target of denial of service attack at some point. So these are things that I think we just have to consider for the broad use cases. I'm not saying anything specific to ILA in this case, but definitely want to see some really solid explanations for why denial of service is mitigated, for instance.
Yeah, and as you know, that's something that we are aware of course, and we are actively looking into, and that we have discussed different options to approach that. So that's...
So this is Albert. Regarding denial of service attacks to the control plane, we have worked in the past on solutions for that. We're planning to release a document explaining how you can solve that, and you will see all the details. But to me, the main point is that these kind of infrastructure where you have a cache and a control plane, they are very common in IT, and there are many solutions around. So it's a very well-known problem with many well-known solutions.
I wanted to make, this is Tino, I wanted to make one comment about sending map notifies over TCP. Since you might subscribe to a lot of different EIDs that are spread across thousands of map servers, and they don't need to send you a notification until something changes. At that time, if the TCP connection is established, you have the three-way handshake delay that will cause convergence problems. And you can't do this a priority because that means every map server would have to have a TCP connection to every ITR in the internet. This is not a scalable solution, even though the big data centers of the world have thousands of TCP connections. This is orders of magnitude more.
Okay.
Okay, thank you. Please.
Okay, so this is just an update on the ground-based LISP document which we presented in last IETF in Singapore. The draft was renamed, by the way. So just a reminder about the where this workbook is coming from. The ICAO is proposing to replace the existing services with a next-generation IPv6-based infrastructure for air traffic management. So the draft itself hasn't changed, but the co-authors of the draft, who are involved at the ICAO, at the last ICAO meeting, which I believe was in March. Okay, sorry. So first point was there was some evaluation done by a third party who were comparing a LISP-based solution using OpenOverlay router and the IROKI solution. The main difference which they found was that there's initial packet loss with LISP. That's what Alberto, I guess, was referring to when you don't have your map cache, and there was none with IRO. So that was one of the major things at the last ICAO meeting. And also, the co-authors of the draft from Frequentis, they presented how ground-based LISP addresses the selection criteria for the mobility solution. So we had some discussions with them, and they presented that.
Maybe just one comment, Fabian. So the first packet drop is a well-known
yes.
Aspect of using the LISP protocol, and there are well-known solution ways to address that. Yep. Common applications that we have today. What we have seen is that those applications don't care typically, so yep. We just drop the packet on the floor, and then all the ones will be routed. If for a particular application that is important, typically we set up a PXDR where the mapping is, and we send the traffic there, and then
yep.
And then the traffic gets for or an RTR or PXDR.
Yep. Yep. Yeah, and it's a good point. And in their case, they do care. The initial packet loss, we discussed the packet loss with them, and dropping the first, packet or two packets is a big deal in that environment. The next ICO meeting is going to be in May. We're going to give feedback, the feedback that Fabio has just described about how the initial packet loss can be avoided using an RTR, for example. And then the feedback the Frequentis co-authors got was they really want to understand how LISP supports multicast. And somebody named TBD is going to be presenting there to see how that actually works. And we'd also like to get some comments from the LISP work group. So just a reminder that draft itself is it has no extensions to the protocol. It's only informational, but it basically describes how LISP can be used in that environment, but it'd still be good to get feedback from the work group. And this is
any comment? You can send your feedback as well on the mailing list, yeah? But I guess
it's an excellent read. It's a really fantastic read.
There are two things you can help. I mean, one is multicast and Dino. You can, and initial packet loss. I mean, there are some solution, and as a working group, we can help you to list a few, Fabio, as Fabio said. That it's not something that we cannot avoid.
Correct.
So
An implementation could always queue a packet and send it. It would be non-spec compliant, but if it's that important, an implementation could decide to do whatever it wants, you know? And if they want to receive old packets because they don't want to drop them, so be it, right?
why is not spec compliant? I don't think we specify a policy what to do with the first packet.
Well, you could be right. We might say, we don't say must drop. I don't know, so we say should drop.
Exactly. There was
Yeah.
years ago a discussion on that, and we
This is
said
true.
it's implementation dependent. Now, common practice, as far as I can say, is that we drop. But
Yeah.
it's not a must. So we can
Yeah.
do something else.
But, okay, so maybe the specs soft about it, but all the implementations do it, so.
Eric, not Mark. I know about one implementation that hasn't been open source yet that does queue packets. So just like ARP or any other protocol, you can queue packet for a while, right? You don't want to queue it forever, but.
And in this scenario, our understanding is that number of packets it's not big throughput, so that seems feasible for this use case.
So, just for clarity, so this is not a public network. It's like a really control traffic or something closed. So the point is, can we have a DOS attack coming from the outside? That's the clear point. But because why we drop, is one reason is not to fill the buffer of the queuing of the. Now, if this cannot happen, it's relatively safe to.
So it's supposed to be a closed OK network, but Fabio, I don't remember the details more than I do, but there's also, it's not just one OK network. There's maybe the North American part, there's the European part, and how do you connect those together and those kind of things. So it's not just a simple flat networks, but the security thing has definitely come up a few times in discussions.
Okay.
So Victor Moreno, so just to build on the conversation that's going on in the room, I'll encourage the group to really have a read. It's an easy read and it's a lot of food for thought. You'll find implications also on the applicability of the pub sub that has been proposed. You will find implications in this multi-regional network on mobility. Thought on how you would do that best. There's some proposal on the draft, but it's not necessarily immediately using things like DDT. So there's a lot of thinking that can go into this. So I think if nothing else, it'll inspire maybe even some other drafts.
Okay. So please all read the draft. Thanks. Now we have a remote presentation. Actually, Fred will come remotely on the stage. I will put his. Here we go.
Do you have me now, Luigi?
Yes, we do.
Okay. So some history about this draft is that it was first presented at the LISP working group back in Prague, IETF 99. And it's called a simple BGP-based mobile routing system for the aeronautical telecommunications network. There's going to be an IP prefix per airplane. The airplane is a mobile Internet of Things. A BGP-based routing system in a hub and spokes arrangement with a core autonomous system in the middle and hub autonomous systems out at the data link service provider subnetworks. Mobility, traffic engineering in the stubs, stable routes in the core, and it's multi-link capable. So where you see the airplanes having multiple links into the aviation data link subnetworks, that's the multi-link aspect of it. Next chart. I'm still waiting to see the next chart. There it is. So in the edges, we have what's known as the Aero IPv6 mobile networking services. And again, the airplane is a mobile IPv6 network. It could have millions of addressable Internet of Things entities on board, and it can connect to multiple data links simultaneously, like SATCOM, LDAX, Aeromax, 4G, 5G, and others. We have traffic engineering for inbound and outbound data link selection. Some of the data that would be carried would be CPDLC, which stands for Controller Pilot Data Link Communications. And it's essentially a command and control for air traffic controllers to talk to the airplanes. Voice and video might go over SATCOM, and we might spread traffic over different data link types based on the traffic type. We can use multiple links simultaneously, replicate traffic across multiple links for fault tolerance. But the most important thing is that the airplane can always be tracked by its IPv6 prefix, and communication sessions survive mobility and data link handovers. Next chart, please. Still waiting to see it. It's a lag here, I'm sure.
There is some delay in the slides.
Yeah. And the main architectural change since the last version that I gave in Prague is that we developed a new architectural construct called the Aero proxy. The Aero proxy sits at the data link subnetwork border router, and it acts the same as for an enterprise network web proxy. So inside the data link subnetwork, the client airplane interacts with the proxy in the same way that it would interact with the server in the outside world. Outside the subnetwork, the server interacts with the proxy in the same way that it would interact with the client. And IPv6 neighbor discovery control messages are proxied in the manner suggested in RFC 4861. So that's the main architectural change, and it's a big component of the architecture now, the Aero proxy. And that's all I have for presentation materials. As Rashad just mentioned, we did have this discussion at the last ICAO meeting, and there's going to be another meeting coming up in May in Montreal to talk more about the Aero and the LISP approaches.
Okay, there is any comment on the room or question? No? Okay. Thank you very much, Fred.
Thank you.
And Dino.
Thanks. I know this works because I was up here this morning. So.
Takes a few seconds to set up. Wait. Because at least in my case, now it's too long.
So what I did last time was I just came in and came out. And then I had to do this. Okay. Okay, we presented this morning in DNRG, and it's just kind of a repeat. It was high level because not everybody was familiar with LISP, but I think you guys will get this much better. So Colin and myself got together and said, how can we bring applications, decentralized applications together with a network layer that can be decentralized as well? And that's the basis of this talk. We're going to talk about how we can decentralize the mapping system. And it turns out that we have the ideas are relatively simple, and most people will get it. And we didn't have to make any protocol changes. You have to make some implementation changes depending on what set of protocols you use. Okay, so the problem statement is, what if LISP XDRs didn't have to depend on a third party? In other words, go out and talk to map servers in a mapping system. What if LISP XDRs could multi-home and roam to inform each other about their RLOC changes rather than being notified by the mapping system? And what if XDRs could be their own mapping system? Okay, so let's build a purely democratized and decentralized control plane. And as always in my presentations, green is the IDs and red is RLOCs when we refer to addresses or links. So everybody in here pretty much knows what the mapping system looks like. This is just showing how the east and south LISP sites are registering to the right mapping system, and the north and west are registering to the left one.
in how the mappings between the EID space and the two locators here are registered. And we know that we're depending on infrastructure that's inside the internet or in our loc space. So what can happen though is that maybe these sites have backdoor connectivity, and usually it is via wireless. And so maybe the south and the east on the same Wi-Fi network, or they can communicate through local towers because they're geographically close or have some reference of locality. But what happens if we have a situation where they really don't have internet access? So how could they keep roaming? How could they keep changing their RLOCs and notify each other so they can keep encapsulating in these backdoor networks that can run? So as you guys know today is that basically when we register these mappings, we basically send EID prefixes and RLOC mappings to map servers, and we send them to each one. So they're configured as unicast addresses, and we either do it via UDP or we do it with TCP. Okay, pretty straightforward stuff that we've been doing for a long time. So let's see if we could decentralize the map server. Okay, what if each XTR was a map server themselves? And what if each XTR could map register to each XTR? The mapping system would then always be synchronized because they'd be all telling each other all of their mappings. And then the XTR could be a map resolver for itself. Since everybody has synchronized mappings, you don't have to go to an external map resolver. You just have to basically send a map request to yourself or do something internally if you want to make it faster. So let's first define a mapping system and what a consolidated or decentralized mapping system could look like. A consolidated mapping system is identified by a multicast group. Let's just make that a fundamental definition. And then the XTRs that are part of the same mapping system will join the same multicast group. They'll be receivers of the group because they join it, and they'll also send to the group. So it's not a one-to-many, it's a many-to-many sort of multicast relationship. The map registers are then sent to the group, and that therefore all XTRs that are joined to that group will receive the mappings. And then we get efficient distribution of these map registers, because if the underlay supports multicast, the XTR is only sending out one map register, and the underlay is replicating it, getting to all the places. If the underlay doesn't support multicast, we could do head-end replication by using signal-free multicast. So what happens there is that the map register from the control plane would be sent down, and the data plane would know if there's underlay multicast or not. And when it's not, it would do an SG lookup according to the signal-free spec to find out who all the ETRs are, and it would head-end replicate to all of them.
Okay, this seems to be a slight difference between what's in the draft and what you just said, in that this seems to say there is a multicast group that is all the XTRs participating in the LISP mapping system.
Yes.
The draft seems to talk about the XTRs forming peer groups and forming multicast among those peer groups. And
this is the peer group.
The peer group is all the XTRs. Okay.
Peer group is all the XTRs, yes.
I have concerns about the scaling of that, but I at least understand how it works.
So if all the XTRs that want to encapsulate, well, let me explain how it works first, and you jumped ahead, right? Let me explain how it works, and then I'll answer your question. So here we have 3 sites that are on the left-hand side that are part of the same mapping system. They're 1, 3, and 5, and they're registering their EID prefixes. They are all joined to multicast group 224.1.1.1. They send their map registers to 224.4.4.1, 224.1.1.1, and then they all have the same image mapping in the mapping system. The right-hand side is just another set of XTRs doing IPv6 that are building their own mapping system. Okay, so that's fundamentally how it works. So in this case, mapping it to the spec, we would say that 1, 3, and 5 are all part of one peer group. If that wasn't the case, and we wanted 1 and 3 to be only in part of that peer group, and 5 was still had connectivity, the XTRs 1 and 3, then all we would have to do is send map request messages to the multicast group. And when you send map request messages to the multicast group, what happens is 1 and 3 would receive the request, and they both would respond. So there's ways, Joel, that you can not be part of it and have the peer group just be a set of map servers So we specify in the spec that a map request can send to a multicast group. What we haven't specified is end messages come back. Is that a good, bad thing? Can we scale it better? Because there's no election mechanism between 1 and 3 to say, I'll answer the map request or the other one will. So.
Dino, this is Victor.
go ahead.
Did you guys consider using any cast instead of multicast for the requests?
The problem is, if you are in a situation where you have the internet and you're using it, what we wanted to work for also is in neighborhoods that maybe all your connectivity is lost to the system, and so you need to auto-discover each other because XTRs are going to be added and deleted. And so by using any unicast address, there's no way you can auto-discover things. Don't forget, normally how we auto-discover things is using multicast, or we use directory services. Well, if you use directory services, you're depending on a third party, right? So if I am always configured that you're my next door neighbor, and I'm always going to use you as a map server, then we can use, and then Padma has another neighbor that is a map server, and we use the exact same IP address, and therefore it's Anycast. I'll get you, and she will get her neighbor, right? And so we could do that, but that means you'd have to pre-configure these things. We want this to work just like a cryptocurrency will work on a peer-to-peer network, where everything is pretty self-discovering, like mesh networks. That's the whole point. We're basically borrowing the applications from the cryptocurrency world and trying to build it here. Now, it kind of looks like a routing protocol, but it's really not because it's done over the top. We're just multicasting things with efficient distribution, right?
And
Tom Herbert. So when you talk multicast, you're actually talking real multicast in this case, right?
The XTRs join Class D addresses, or FF::/8 and IPv6. And so the multicast service model is available for this control plane, yes.
Okay, so my impression is multicast may or may not be available in most networks. I worked in 2 really large provider networks, didn't have it. I know a lot of provider networks don't have it.
Yeah, you missed my last.
So we're doing something different there, right?
You missed my point there. If the underlay does not support multicast, we can do head-end replication by taking multicast packets and encapsulating them in unicast. That's what Lisp signal-free multicast does.
Okay, so if I'm doing that replication, then what's the point of multicast if I'm doing a map request? Why not just send it to one?
Because you don't know who to send it to. See, the thing is I need to send you a map register, but I don't know your RLOC. Well, the whole reason I'm running the mapping system is because I want to discover your RLOC.
So you're trying to register. You're trying to register with everyone simultaneously.
You're telling everyone who your RLOCs are, essentially, and when they change, you
And
re-register.
what happens if they miss the unreliable multicast messages?
Well, you send them periodically, or you run a reliable multicast transport protocol, which could be added to this in the future.
Ooh.
Yeah, but you start piling
That's
up
kind of
complications. I can understand this in a small case of a moderately small set of things which want to use Lisp, which are all on a common fabric which supports multicast, so that all the scaling properties work and all the benefits work. But as a general mechanism, this seems like it's going to need so many complexities by the time you're done for the general deployment case that it would be
we're not saying
counterproductive.
We're not saying it's a general mechanism, and I'll show you the use cases we're targeting.
Okay, but the draft doesn't tell you what use cases you're targeting.
What's that?
The draft doesn't tell me what use cases you're targeting.
Fine. Well, we try to keep marketing materials out of the draft, right?
Yeah, but I need usage.
Okay, so.
I had a small question here. How you discover the multicast group you have to join?
The multicast group is
how an XTR knows now I have to join.
That's configured.
2 to 4 by configuration.
But if you could configure that, you could configure something else. Keep one XTR running all the time and give his address as the.
But you don't know if the XTR is going to be on your side of the partition or not. That's the problem. If you always pick somebody, then you might as well just statically configure all the RLOCs and the map cache entries and don't even run a mapping system. And that can be possible too. But if you configure static mappings with RLOCs and they want to move around and change their RLOCs, you have a problem. So that's why you need multicast for the dynamic discovery. Okay, what are the benefits? Well, the XTRs only depend on each other, and they already do if they want to talk to each other, so it's not creating a new dependency.
Which means there's no authentication.
That's not true.
There's there's no authenticated delegation. You can authenticate to each other as participants,
Yes.
but you don't have any delegation, authenticated delegation of EIDs in this system.
So if you use our ECDSA draft, the instance ID is part of the signature. So you can verify the signature. So if you try to register
No,
to me.
that's a different approach from authenticated delegation. That's how you're solving it.
You're allowing what XTRs are allowed to, you're basically not creating an input filter on saying, I'm not going to receive something from that neighbor over there, even though I don't know if it's Joel or Luigi, right? The thing is you will register by signing the map register, and then I will look up in our database the public key, and I'll verify the signature to make sure that it's Joel that's allowed to join this particular multicast group in this instance ID.
So, but this had a second dimension. You need to know the multicast group, okay, by configuration,
Right.
and you need to have the public key or all the people that could potentially join this group.
So-
am I wrong?
You do, and the public keys are registered, and they don't have to be authenticated. Registering a public key is harmless, right? The question is using it, and what you're verifying, that signature data is what's the precious stuff, right?
Yeah, but now we fall back to the question of scalability, because such mechanism for big deployments
Right,
is
okay.
complex.
Right, understand. So in this case, there's no third-party trust or dependency that exists other than in each other. And the map request lookup is pretty low latency because it's a local operation. You don't have to send it to a third party. Can I finish the slide?
Sure,
or you want
please
to,
do.
or do you have a question on?
Yeah, it's on the second, this is Alberto, on the second bullet point, no third party. The way I understand it, and maybe I'm wrong, is that actually you have full trust, right? You are trusting all the participants on your multicast group. There is no way to verify if what they are telling you, they are right or not.
Well, if I want to make a phone call to you and you tell me your phone number, I have to believe you it's your phone number if I want to talk to you.
That's why, yeah.
So yes, you're trusting each other, but if you want to talk to each other, you have to make sure who you want to talk to is the one who's giving you the mapping, but you can verify that with the signatures, right?
But how do you verify it with a signature? How do you verify it?
So
how do I know that you are authenticated for a certain EID preference?
Okay, so let me explain how it works in more detail. So we're all in a neighborhood. We lost internet connectivity. We want to talk on our radios to each other. We're in some signal range, so we know that we can get packets to each other. So what happens is we all register our public keys to this multicast group address. And so what we're registering is a hash of a public key to the mapping system with a public key.
And
that's happening just without any signature.
This is by configuration.
What's that?
The hash of the public key, how do you receive it? It's by configuration?
You create key pairs up front.
Yeah.
And then part of running the ECDSA authentication draft that Eric and I published, you sign it using the private key over some signature data that includes the hash of the public key and the instance ID.
Okay.
And then that map register goes to everybody, and they verify it by looking up the public keys that they have local in their database because it's been distributed.
There's another mapping system.
Yeah, but the authentication
same.
of that map register is done with the shared key, right? So you need to authenticate who is registering the...
Right. It could be done with a shared key or no key, depending on how open you want it to be, right? Everybody in the same neighborhood that plans on having a hurricane or an earthquake or something could be pre-configured with the shared key, yeah.
Okay, so it's a local, but and that registration...
Well, if that's not there, you're going to say anybody can register their public key, and the answer is that's fine, they can, but it doesn't mean it needs. There's nothing wrong with registering a public key to the system, other than you're worried about DOS attack on
No,
the
but
memory.
I can register your public key, right, and get... I can register a public key pretending to be you.
Right. Right, but you mean you have to guess it too, right? You have to guess my public, you have to
No,
guess the
I register a public key that I just generated associated with a private key, and I'm telling everybody that I'm Dino. And then everybody in this room is going to trust me.
What's Dino? Is Dino the EID?
Yeah.
No, because if it's registering IPv6 address, that's the EID as well.
Okay, because in EDC, in the public key draft, you are using EID that are public keys.
Yes.
Okay.
What you are registering is a crypto EID. The crypto EID is a hash.
Yeah, that was the missing.
Okay, that was the missing part. Got it.
Same here. Now I understand. Thank you.
Okay. Oh, so you guys are saying that if I was registering an IPv4 address, it would be a problem. Okay, good point. Okay. XTRs then build and send one map register for NXTRs. So that's important because the distribution is being done by a routing layer versus building separate messages. So really the control plane just has to build a single message, even though it's going to many places. The distribution is being done at the network layer. Management is pretty simplified because you have by accessing one XTR, you can get all mappings, very similar to a link state protocol. So you don't have to, rest into all because today the third-party mapping system is a shard where each map server is doing horizontal partitioning of the mapping. So if you wanted all the mappings in the mapping system today, you'd have to go access all the map servers. I don't know why anybody would want that, but it depends if you want to sell it, I guess you could. So this is pretty much like peer-to-peer networking, but it's being done at the network layer. Okay. So here are the high-level use cases. We believe that this can go with cryptocurrencies, where maybe mining pools could be associated with a multicast group, and we want the miners to be in their own mapping system, and it's closed and authenticated. Maybe we want certain sets of wallets to talk to certain miners or certain peer-to-peer networks. So we think we could do all this without relying on a third party. Emergency networking is the use case I just mentioned, where you have a neighborhood where there's a hurricane or earthquake and you lose connectivity to infrastructure, but you have wireless connectivity and you still want to roam around between, if you have local LTE or Wi-Fi Direct or something like that, you want to do that. In data center applications and IoT edge computing stuff, we're going to find microservices that we're going to launch containers, bring them down, and they may change they may move while you bring them up and go down. And so we might want the decentralization mapping system to be among those things. We think there's going to be some use cases for deploying routers and stuff in space, where we think there'll be some software-defined satellite type applications that we could use this as well. And it just kind of falls in with the general shareable economy apps where you want to pay for renting out resources to people, either bandwidth, CPU, whatever, routing, frequency or whatever. So we did this in a brief demo. We used 3,000 containers, Joel, no, only joking. We used 3 containers, each running lispers.net XTR, and the Docker container stuff did not do it multicast in the bridging. We actually had the bridge turned off. And so the XTRs were doing head-end replication just to show that we can use them.
Which means that they actually had to be pre-configured with the addresses of all the other XTRs.
Absolutely not.
How could they replicate to something they didn't know?
Watch. XTRs register. Okay, so what the demo's doing is the XTRs register IPv4 EID prefixes and a name as an EID. Okay, so here's an example of the first container, and N1 does 111/32, N2 does 222. So you see they're all sitting there. So this is showing the result, okay? And I'll explain how the result is achieved. This is the second one that obviously has the same set of entries, and then this is the third one. Well, what happens is that they all join 224.111 because that was the only thing that was configured was the multicast group. And so what they did is they started sending their map registers to 224.111. Now, how you bootstrap it is you first send it to yourself, and then that gets added to this. And then once that happens, all this guy needs to know is about one other guy, and That's what we have.
But how does he ever learn even one other guy?
Huh?
How does he learn anybody else but himself?
All you have to do is one other guy, let's see. I'm trying to remember how I implemented it. You mean how, you're saying there's a circular dependency here?
Yeah.
We got out of the circular dependency.
But how? I believe you did.
Yes.
But I can't guess how.
So the way I did it first was so the map server on each one of them was configured to be 224.111 and 127.0.0.1.
Right.
Okay. So we sent the register to ourselves and we got the first entry, right? And then, I can't remember the configuration because I evolved a couple times.
If you were on the same
Can I tell you on the list? How does
you'll
that
have
go?
to tell you,
Yeah,
you'll have to
'cause I
tell us
can't
on the
remember
list.
in real time.
Because if you're on the same subnet, yeah, you got subnet multicast.
Oh, no, it doesn't depend on, well, we were trying to show where we were using the Lisp data plane to solve the problem as well. Right. But yeah, clearly if 224.111 was available on the local area network, which it can be, a lot of times these radios will run layer 2. So maybe in an emergency situation, you just depend on layer 2, right? But you don't want to really necessarily depend on a layer 2 overlay, right?
No.
That would be a bad thing. And we're not doing an L2 overlay here to realize multicast. It's doing layer 3, okay? Okay, so this is just showing here that when they all join 224.
We're out of time.
Oh, okay. Should I stop?
And I've got to run.
Oh, okay. Okay, so this is just showing that here's the replication list for the RLOADs.
But once I have them, I can replicate it. I get that.
Yeah. How do you get them in the first place? Yeah, right.
So for the question or comments, take it offline because
Yeah.
we are over time, or contact on the mailing list to Dino. Okay, thank you very much. See you next time in Montreal.
So let's see. So I think in this case, you have to run or?
Yeah.
No, okay, let's do it. I was trying to. I want to know how that works. Oh, yes. I'm reloading. How are you doing? Oh, I am doing.